we have been discussing about the photochemistry of carbonyl compounds. So we have mentioned earlier that the carbonyl compounds undergo 4 different types of photoreaction. The Norrish type 1 reaction, which is alpha bond cleavage; Norrish type 2 reaction, the gamma hydrogen abstraction by the excited carbonyl. Third one is photoreduction. Fifth one is cycloaddition reaction. We have already looked into the Norrish type 1 and Norrish type 2 reaction is very common in aliphatic ketones, and we have already looked at a few examples. And the most important reaction given by Norrish type 1 reaction is the alicyclic ketones. When we have a cyclic ketones, it undergoes alpha bond cleavage to give acyl radical and carbon center radical. If alpha substituents are substituted, if alpha carbon is substituted, then there will be a preferential alpha bond cleavage to give more stable carbon center radical. For example, if we have a system like this, say for example acyl ketone like cyclobutanol, under photolytic condition, it will undergo type 1 reaction, and then which is nothing but alpha bond cleavage, right? So this is alpha bond and this is alpha bond. So this is alpha carbon and this is also alpha, say for alpha diazide. If one of these, so we can, when it is symmetrical, then we can cleave any of these, is going to give no problem. But if the alpha carbon is substituted, say for example, if it is substituted by one of the alpha carbon is substituted by 2 methyl groups, then it is going to be a preferential cleavage, because this cleavage is going to give you a primary carbon center radical. This cleavage is going to give a tertiary carbon center radical, because the other side, the acyl radical, will be common in both the cleavage. So tertiary, we know that the tertiary is more stable than the primary, and therefore this will undergo a preferential alpha bond cleavage. This will cleave to give a diradical like this. This is the first step. There is a diradical species. So preferential cleavage. So it is going to give preferential cleavage. Not only this will cleave and not the other one. So it is going to give a preferential cleavage, this one, and then this will undergo different types of reaction. The most important is the decarbonylation. First path is decarbonylation. Second is the aldehyde hydrogen atom abstraction. So give an aldehyde, and then it also give fragmentation to give ketene, and the first, this is second, this is third, and then fourth one is the ring expansion. So let us see one by one. If it undergoes decarbonylation, is going to give a diradical like this. This will combine to give a cyclopropyl derived product. This is one of the product which is going to form after decarbonylation. Hydrogen abstraction, this will abstract an hydrogen, abstraction of the acyl radical, followed by the formation of the double bond here. So this is going to give a product in aldehyde. Fragmentation is this one. This will go like this, and then this will so I'll just remove. Will go like this, and then this will, so this will go fragmentation to give this one plus ketene, ketene as intermediate. Ketene is less highly unstable. And lead to give say for example alcohol, if the reaction is carried out in alcohols, it will lead to an ester, C double bond O, OR, so it will give an ester, and of course this is an alkene. Ring expansion product is of course there is a double bond here, right? And then the other one is ring expansion product is a very important reaction, because from 4-membered is going to give a 5-membered with oxygen containing heterocycle. This is really extremely important product as far as the photochemistry of alicyclic ketone is in expansion. So one of these radical is attacked here, and then this will go like this. So now it is a part of a cyclic system. If we compare, if we number this, say for example 1, 2, 3, 4 and 5. So 1 is a methyl group, 1, 2, 3, 4 and 5. And then at a 4 carbon we have a ketene. This is carbene. Carbene is carbene as the intermediate, and this in the presence of alcohol, ROH, is going to give a corresponding OR, and then this is H. Of course, this is an extremely important reaction which we have already seen. So these are the different pathways open. One, decarbonation. Second, hydrogen abstraction to give an enaldehyde. Fourth is fragmentation to give ketene, and fourth one is the ring expansion product. Now, different, as we have seen that the ring expansion product, the alpha cleavage is preferential, and hence there is a problem, right? Problem, right? Ring expansion product only. And so when the irradiation of the following ketone, when the photolysis of following ketones are carried out in methanol. So methanol is a solvent, and there are variety different ring expansion. There are different cyclic ketone following. Write the ring expansion product of photolysis of following alicyclic ketones. Alicyclic. So there is a large number of alicyclic ketones. This is one. Second one is this one. Third one is dimethyl substituted. Dimethyl, both the alpha. Fourth one is again dimethyl substituted with an alkene here. Fifth one is a cyclopropyl group, and then the sixth one is again so there is a series of 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and then there is one more, but doesn't matter. Okay. So what we have, these are all carried out photolysis in the presence of methanol. Photolysis of the following ketones have been carried out in methanol, and we have to write only the ring expansion product. As we have seen the alicyclic ketones, there are 1, 2, 3, 4 pathways are available, giving rise to different products. One is the cyclopropane derivative or the enaldehyde. Third one is the an ester plus an alkene, and fourth one is the expansion product. So in the next series only we have to write the ring expansion product only, and for this we have to very carefully see the cleavage of the alpha bond. So all this will undergo type 1 reaction, all will undergo type, because they are all will undergo type 1 reaction, because these are all alicyclic ketones. And if the alpha carbon is substituted, say for example this is alpha carbon is substituted, this is alpha also, this is alpha, both are substituted, this is also substituted, and then this is also substituted, this is also substituted. So when alpha carbon is substituted, we have to see the preferential cleavage, and also which radical is going to be, whether the radical is going to be stable or unstable. For this, let us see, this we have already seen. So there is no alpha carbon, alpha carbon is not substituted. We can cleave any of this, so we can just cleave this to give a diradical. This will attack here, and then it will going to give a 5-member ring with a carbene intermediate, and then methanol as a solvent is going to give a product like this, OR and H. So this is a reasonable product and possible ring expansion product in first one. Now see this. Now this is unsubstituted. If we cleave this, we are going to end up with a primary radical. If we cleave this, we are going to end up with a tertiary radical. So we have already seen the first one. So this will go preferentially cleavage, preferentially alpha bond cleavage to give this radical, and then this will attack here, because this will not cleave here, because this is going to give a primary carbon center radical. Acyl radical is same in both the cases. So this will add in this fashion to give a. So this is a figure. Let us number this 1, 2, 3, 4, and just to avoid any mistake, 2, 3, and 4. 1, 2, 3, and 4. So the carbene is going to be formed on the 4th carbon, and then the attack, the first carbon attack on nitrogen. Oxygen, not nitrogen. Oxygen is the part of the ring. Now in the presence of methanol, is going to give a product like this, OR and H. So this is a possible product in this particular case. Now we can see here both the alpha carbons are dimethyl substituted, so we can cleave any of these. We can cleave this or this. So this going to give a same stability product. So if we cleave this, we end up sorry. So we are going to give this as the, so this is going to attack here. Then again oxygen is a part of the ring. So let's number this 1, 2, 3, and 4. So 1, 2, 3, and 4. That's oxygen, of course. 1, 2, 3, and 4. There are 2 methyl groups on 4 carbon, the 2 methyl groups on the 3rd carbon, and then so third is going to be third is going to attack oxygen. Third is going to attack on oxygen. So Third carbon is connected to oxygen. Fourth carbon is here, right? So third carbon is attack on the, so is the link between third carbon and oxygen. Then we just connected to this 1, 2, 3 oxygen and 4. So we have a dimethyl on third carbon, another dimethyl at first carbon, and then you have a, on fourth carbon we have a ketene. This is your fourth carbon. Now this in the presence of methanol, we're going to then we have sorry, let's write the same way what we have written. Dimethyl here is OR, ORH. So is the so whether if we say for example if we cleave this, so it is going to be the same product. Only thing is that which going to whether we can, if we cleave this also is going to be the both the oxygen is going to be adjacent to one of the methyl group, and then there will be a addition of a methanol carbon, and then is right. Now again here is dimethyl, both the alpha carbons are these alpha dash, both the alpha carbons are dimethyl substitution, so there will be a preferential cleavage. We can cleave this or this, any of these we can cleave, so we end up with a radical here, and then there is a double bond, right? So and then let us give the number 1, 2, 3, 4. 1, 2, 3 and 4. Now this is going to attack on this, and then right. So oxygen is the part of the ring. Now there is a carbon number 1 is going to attack link between oxygen 1, 2, 3 and 4. There is 2 methyl groups from carbon number 1 is a the ethylene group as carbon number 2, and then there is 2 methyl groups as carbon number 3, and then there is a 4 carbon, there is a ketene, and now CH3OH, and then is going to get a ORH. So this is a possible ring expansion product in this particular case. Now we can see here there is a cyclopropyl group. So with the dimethyl substituted, there is a cyclopropyl group. So so this is a one of the carbon is a, there is a bicyclic system. So we can let us cleave one by one. So if we cleave this, we end up with a, if we cleave this, let us see this one is more proper way. The dimethyl group. So let us, this is alpha, this is alpha dash, is alpha bond H nu, is a type 1 reaction, alpha bond cleavage. If alpha then if we cleave this, we end up with a radical here, a cyclopropyl group here. This is a primary radical. Acyl radical in both the cases. Let us cleave this. Cleavage of A, and then cleavage of this cleavage will going to give a C double bond O. This one. This is a this is a primary radical. This is a tertiary radical, and of course there is a, now there is a now we have to see the stability. This is a, we know that the stability of the radical lies in the tertiary is more stable than secondary, is more stable than primary, is more stable than methyl radical, right? So this is the order of this, but still there are situations when the radical is unstable. I just discussed this before also. Radical on the cyclopropane ring is unstable because cyclopropane is under ring strain, and any is already is a lot of deviation from the standard bond angle, and hence is already this highly under strain. Bond angle is 60 degree. A normal bond angle is 1092.28. So higher the deviation from the standard sp3 hybridized carbon angle, more strain, and hence that's why, because of this high strain, the banana type bonding is proposed. So a radical on the radical on a strain ring system is going to be highly unstable. So this radical is not going to be, although it is tertiary radical, but cyclopropane being highly unstrained, radical generation on the cyclopropane is unstable. So this radical is unstable because if radical is formed adjacent to the cyclopropane ring, this is really going to be, this is stable, because cyclopropane is considered equivalent to a double bond and then is going to stabilize. So adjacent to a double the radical adjacent to a carbon next to the cyclopropane ring is stable, but the radical on the cyclopropane ring is unstable. So because of the high ring strain, so this is unstable, and hence this will not form. Although it is a primary radical, this will form, and then this will lead to the product. So this is going to form, and then this will lead to the product. So we can number this 1, 2, 3, 4, 1, 2, 3, and 4. So this radical is going to attack here. So we are interested, the question is to write only the ring expansion product. So this will attack here. Oxygen is the part of the ring. This is 1, 2, 3, and then this is 4. 1 we have of course there is and then on the third we have a cyclopropyl group with a dimethyl, and then 1 is going to attack oxygen, and then the carbene is going to be on carbon number 4. So this will, and then the in the methanol is the solvent, so the product, so it's going to CORH. So this is the possible ring expansion product in this particular case. This is really important question, and it is we know that this is alicyclic ketone, and the alicyclic ketone under photolytic condition undergo type 1 reaction. Type 1 reaction is nothing but is a gamma hydrogen, a gamma bond cleavage. If the alpha carbon is substituted, then we have to go for stability of the carbon center radical. But in some occasions, the stability is, it is not only the tertiary, doesn't follow always the tertiary is more stable than secondary, is more stable than primary, and so on and so forth. But in in special circumstances, when the cyclopropane ring on the radical on the cyclopropane is unstable, and radical on the double bond is also unstable. So these are the situation. The radical will not go, and although a primary radical is less stable, but this will be this cleavage is going to be preferred because this will lead to less stable and unstable radical, and then this will proceed to the ring expansion product. So if somebody writes this one and somebody writes this as a ring expansion product derived from this, like attack of this, and then a carbon radical here, is going to give a wrong product. So we have to be extremely careful while writing, going for the the alicyclic ring expansion product, when the alpha carbon is substituted, we have to see what is the substituent, whether it is a adjacent double bond connected to the ring, then it's going to unstable. With a cyclopropane ring in the form of a spiro ring system is unstable. But if it is a part of a substituent, like say for example we have already seen, then if it is a part of a like this, then it's really going to be this radical after cleavage is going to be stabilized by the cyclopropane ring because adjacent to the cyclopropane. So this is going to be a preferred cleavage. So this is going to be a preferred cleavage because this is not on the cyclopropane but adjacent to the cyclopropane, and then a ring expansion product will be the one like this. So we can have a part of the ring, and then if let us number this is 1, 2, 3 and 4, 1, 2, 3 and 4, 1, 2, 3 and 4. So there is a 3, there is a cyclopropyl ring, 4th carbon, 3rd is going to be oxygen, 3rd is going to be on oxygen. So there will be a oxygen, third carbon is going to link with oxygen, and then 4th is here, right? 3rd carbon is linked to oxygen, so this is the carbene. This is a carbene, and then this is going to in the presence of methanol. So this is R, this is H. So 1, 2, 3. 3 connected to the oxygen, and then 4th is. So this is the possible ring expansion product from this as the starting material. This is the starting material, acyl ketone, and this is the possible ring expansion product. Possible ring expansion. So these are so we just left with one more, this one, and then here also we can see that the let us see this in another example. We have a double bond O, and then of course there is a double bond here, right? So this is the last example to see. We are the question is to write only the ring expansion product. So that is H nu under photolysis. It will undergo type 1 reaction. Type 1 reaction is alpha bond cleavage. And this is alpha carbon. This is alpha carbon. Alpha carbon is substituted, so we can see the both the one of the alpha carbon is substituted. This is one. This is a primary radical, and then if we cleave this, we are going to generate a radical on the cyclopropane. So this is the we have to see the stability of this radical as well as this radical. Now this is a primary, this radical on the double bond. So we have just now mentioned that under special cases the radical on the double bond is unstable. Radical on sp2 hybridized carbon is unstable. So this is unstable. Radical on the cyclopropane is unstable. Radical on the double bond is stable. But radical adjacent to double bond, so if we have a radical like this, this is stable because it's going to be delocalized. Here is on the sp2 hybridizing, so this will not form. This is, although it is a primary, this will form. This is the first step. and then the ring expansion product is going to attack here, is going to attack. Of course, there is oxygen is the part of the ring. Now we can give this number 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. So 1, 2, 3. There is a 3 carbon, there is a double bond. There is a 2 methyl group. Third carbon, there is a double bond, there is 2 methyl group. And then 1 is going to be oxygen. Fourth is going to generate a ketene, carbene intermediate. And then this in the presence of methanol. Methanol is going to get a OR is H. 2, 3, 4. 1, 2, 3, 4. 4 is the methanol. So this is a possible ring expansion product in the. So we have already looked all the example. We have written out the possible ring expansion product in all these 4 cases here, and there is a 5th case here, and the 6th case here, and so this is for today. Thank you very much.